And good evening, AP Physics students. We're going to talk about electric charge and electric fields tonight. Congratulations, you have survived your study of mechanics, Newtonian mechanics, which is about half of a traditional college physics course. And we are now moving on to electricity and magnetism, kind of our second half of the year. Maybe you could call it a third mechanics, a third electricity and magnetism, and a third lots of other stuff. But let's move on here. Let's talk about electricity and magnetism. So we'll also be looking at problem 4 from chapter 16. So let's start with some basics here. You're going to do some reading tonight, checking out your textbooks, and you're going to read things that you've known for quite a while, right? Things like opposite charges do what to each other? They are attracted to each other, right? So you got a positive and a negative, and they will be attracted to each other. They will accelerate towards each other. There is a force there. On the other hand, if you have like charges, they repel each other. So if two protons are right next to each other, there will be an electrostatic repulsive force because of that charge. As a matter of fact, I believe that's what our problem is about tonight, is how much force do the protons in the nucleus of an atom repel each other with due to their electrostatic repulsive force, all right? So you probably knew that. Here's something I don't know if you knew. In every reaction we've ever witnessed in this universe, the amount of net charge is always conserved. So even in the Large Hadron Collider over there in Europe, where they smash together protons moving at the speed of light and get all these different Higgs boson particles and everything else produced, the total amount of charge in those collisions is always conserved. So kind of a neat conservation law. Other basic stuff about electricity and magnetism, just some quick reading. So some molecules have more charge at one end than at the other end, and we call such molecules polar, okay? Water is our favorite example of a good polar molecule. What else? Most atoms that we come across have the same number of positive protons as negative electrons, but if an atom, say, gains an extra electron, it's no longer an atom, but an ion. You guys all had Mr. Carafel for a teacher at some point, so I don't need to tell you this because you know it, but just little reminders. Other vocabulary, objects that let electrons freely flow through them are called conductors, like metals. Materials that don't let electrons freely flow through them, like plastics, are called insulators. Okay, well, enough review, Mr. Kirsten. Let's get to the basics here. So, like charges repel each other, but being good physicists, we want to know with how much force do they repel each other. We know they repel, but let's quantify this. So the first person to do this was a French physicist named Charles Coulomb. All right, and he invented Coulomb's law, which states that the magnitude of the force of repulsion between two charges is equal to a constant times the magnitude of charge 1 times the magnitude of charge 2 divided by the distance between them squared. Now this constant here, K, we just call the Coulomb's law constant, and it is approximately equal to 9.0 times 10 to the 9th newtons times meters squared per coulomb squared. And I'll bet you're saying, Mr. Gerson, what in the world is a coulomb? A C, that's a capital letter C, by the way, not a lowercase speed of light C. So the SI unit of charge is just that, the coulomb. All right, and we abbreviate that with the capital letter C. So, for instance, the charge on a typical proton is we call E sometimes, 1.6 times 10 to the minus 19th coulombs. And as a matter of fact, that's the kind of the lowest charge you can have. Okay, so Coulomb said that the force between two charges is proportional to the magnitude of the charge. So if I were to double the charge, I'd double the force. But it's inversely proportional to the square of the distance between them. So for instance, if you were to double the distance between two charges, the amount of force would go down by not 2, but a fourth, right? Because you'd square that 2 and you would get 1/4. One other note here, sometimes the constant K is written like this, 1 over 4 pi epsilon naught, where epsilon naught is another constant called the permittivity of free space. And we have enough new stuff to talk about without talking about that. So K is just a constant, 9.0 times 10 to the 9th. If you want to get technical, it's like 8.998 or something like that. But for our purposes, 9.0 will do just fine. Well, let's solve this problem, Mr. Kirsten. Enough of your jibber-jabbering here. So problem 4 states, I've got 2 protons and they are repelling each other. How much force are they repelling each other with? And they tell us that the distance r between the 2 protons, and these are 2 protons in the nucleus of an atom, the distance between them is 5.0 times 10 to the minus 15th meters. Okay, so well, how much force are they repelling them with? Let's go ahead and do our first Coulomb's law numbers here. This is K. The charge on a proton is just 1 times the base unit of charge, 1.6 times 10 to the minus 19th. And there's 2 protons, so it's Q1 E times E, or E squared. And we would divide that by 5.0 times 10 to the minus 15th. And we plug all of that in, and we would get a force of 9.2 newtons, which is the amount of force those 2 protons would repel each other with. Which doesn't sound like a lot of force, but when you keep in mind that these protons have a mass about 10 to the minus 27th kilograms, your acceleration, which is proportional to F over M, would be like 10 over 10 to the minus 27th, which would be like 10 to the 26 meters per second squared. So there must be some mysterious force that's really holding those protons together, which we will learn about a little later. All right, nice work, AP Physics students. So today I have a joke for you, and I'm just going to tell you your joke is your reward for listening. And the joke is a science joke, and it goes like this. There are 2 types of scientists out there. One, scientists that can extrapolate from incomplete information,